You can never fully comprehend how insane a neutron star is. It is so dense that while its diameter is 20 kilometers or 13 miles, its mass is greater than the mass of our sun. Just try to imagine it, 1,000,000 Earths, compressed into the size of a small city. In other words, 1 teaspoon of neutron star matter would have a mass of 1 billion tons. And these mind-blowing facts are just the beginning. Let's take a closer look. A neutron star is born in a supernova, which means a colossal explosion of a big star many times the size of our sun. Here is how it happens. These enormous parent stars have immense gravity, which causes their plasma to press towards the core. But the gravity is pushed apart from the inside due to the constant explosions happening at the core of the stars. These explosions are caused by nuclear fusion, which means hydrogen fusing into helium. Nuclear fusion is what keeps stars alive, and it goes on for as long as there is hydrogen in the core. Once the star runs out of its fuel, iron remains at its core. The immense gravity wins, compressing iron, which cannot generate energy while fusing. Eventually, the star explodes catastrophically, and an extremely dense neutron star remains. It is so dense that all buildings in New York City could fit into 1 cubic centimeter of neutron star matter. This is 1 billion tons compressed into the size of a sugar cube. This is not the only insane fact about neutron stars. Such an extreme density also causes extreme gravity. What you are about to hear can truly blow your mind. A neutron star has an astonishing gravity of about 200 billion times that of the Earth. Firstly, it would be impossible for you to touch even a tiny droplet of neutron star matter. You would be spaghettified long before you even came close to it. But let's just say that you teleported to a neutron star. What would happen then? You would instantly flatten on its surface. And what is crazier, you would become about 100,000 times thinner than a piece of paper. Therefore, if you were able to stay alive on the surface of a neutron star, your life would be two-dimensional. You would be as thick as a few atoms. Speaking of surface, a neutron star's surface temperature can be over 1 million Kelvin. To compare, the sun's surface is only 5,800 Kelvin. A neutron star's crust consists of iron nuclei left from the supernova. As you go deeper into the crust, the gravity increases, and these nuclei come closer and closer to each other. They start forming larger nuclei that first look like spaghetti, then lasagna layers. This matter is known as nuclear pasta, and is considered to be the strongest known in the universe. Neutron stars are also the strongest magnets known in the universe. A newly born neutron star can have a magnetic field quadrillion times that of the Earth. They are called magnetars until their magnetic field becomes weaker. They can also spin over 700 times per second. This means that a point on its surface can travel at almost 25% of the speed of light. Fast-spinning neutron stars radiate beams into space while spinning, which look like pulses. Therefore, these stars are called pulsars, the most commonly known type of neutron stars. When a pulsar was first discovered in 1967 by Jocelyn Bell, she initially thought that the pulses were signals made by aliens. She called it LGM-1, which stands for Little Green Men 1. Some neutron stars exist in binary systems. In other words, a neutron star can feed on another star, eventually turning into a black hole. In some cases, two neighbor neutron stars circle each other, eventually colliding and producing what's called a kilonova explosion. The two neutron stars form a black hole as a result of the explosion. Besides, this explosion might be the origin of heavy elements like gold and platinum. And finally, kilonova explosions create planetary systems, repeating the cycle. Our solar system also originated from a kilonova explosion,